Hi everyone, this is Musa. In this video I'm gonna apply the steps of Walton bookstore problem. So let's select cell D6 to construct our shifted cumulative column equals to this cell plus this cell. Enter. And grab the corner, drag all the way down. So we have constructed our shifted cumulative column, and we're going to use this column in the VLOOKUP function in a smart way by using the idea of approximate match. I'm going to explain this in a second. Step 2, we're going to use rand function and demand VLOOKUP function for the demand generation. So I'm in this cell. We're going to call the rand function. As you know, rand function generates uniformly distributed numbers, decimal numbers between 0 and 1. And I can change these numbers by pressing F9. In this cell, I'm going to use VLOOKUP function to generate demand values. So we're going to use lookup value as this rand function because we are using rand function to imitate the CDF, namely cumulative distribution function. And we're gonna search for this value within this two-dimensional range. And I need to fix this range because I'm gonna generate 1000 simulations. Fixing, I'm pressing F4 for fixing, as you know, comma, VLOOKUP function make an approximate match by looking at this value within this first column, and then it's gonna return the demand value. So I need to select the 2 or second for the generation of demands, and we're gonna use approximate match. I'm gonna explain in a second. So this is the VLOOKUP function. Typing, enter. So for instance, for this random number realization, demand value is 100. So the VLOOKUP function will be looking at this 0.28 value in the first column, and it looks for the what is the closest number to this random number, also which is the less than or equal to that number. So it's gonna be 0. That's why it is returning 100. Let's change it. So this time, what is the closest and less than or equal to number to the 0.34? It's gonna be this number. That's why we got 150. Let's change it. This time we got 0.51, so it's gonna be approximate match is gonna be this 0.50 because this is the point which is closest and less than or equal to this random number. So it's returning 200, and this is the idea. This is the idea of approximate match. Okay, let's continue. So we're gonna calculate the revenue. So this problem is similar to the NCAA problem. So revenue is gonna be the minimum of order size. I am fixing order size because each time I will be using this order size cell, comma, I will be using this changing demand value each time. So this is the amount of sales until February 1st, like the first period, times what is the unit price? It's $10, this cell, and I need to fix this. I will be using always this $10. So this is the amount of revenue in the first period. We mean until the February 1st. What is the cost? Cost is gonna be order quantity times the unit cost. I am fixing order quantity times unit cost. So the unsold calendars return to the publisher for some refund value after February 1st. So we're gonna use the idea of leftover like we applied in the NCAA problem. So for the leftovers, we will be using max function, as you may remember. It's gonna be order size minus demand, or if this value is, this expression returns to some negative value, we need to put as 0. So we may have 0 leftovers, or we may have only positive leftovers. So that's why we are using the max function as we did in the NCAA problem. Times, what is the refund value? It's gonna be this cell. And we are fixing because we will be using the same refund value in all simulations. I think it's clear. Let's hit enter. So profit is gonna be, clearly it's gonna be revenue minus cost plus refund. Enter. And we highlight the first row and grab the corner, and we're gonna double click to copy over all the corresponding formulas in the 1000 rows, like this. You see, by using Control Shift Control, I can see the all simulations. Okay, so we are done in the step 3. Now we are in the step 4. We have generated our 1000 simulations, and we are gonna calculate some summary statistics. So what is the average profit? We're gonna use average function, and we're gonna take the average of by using Control Shift down arrow. I can do this. What about the standard deviation? We're gonna use this function. P stands for population. I'm gonna use Control Shift down arrow. Same idea. What is the maximum profit? We're gonna use, in this position, Control Shift down arrow, close the parentheses. So it's gonna be maximum. So I made a mistake. It's gonna be maximum. What is the minimum? The minimum is gonna be okay. This is the function. So these are the summary statistics. So by using the idea of confidence interval, I can provide two extreme numbers for the profit value. One is like the lower limit, the other one is the upper limit. So for the lower limit, we're gonna use the average profit minus, what is the standard deviation? This is the standard deviation. I need to multiply this standard deviation with the 1.96 to obtain the 95% confidence level, times, and I'm gonna divide this number by the square root of the number of simulations, which is 1000 for this case. Okay. Enter. What is the upper limit? It's gonna be the same, but we're gonna use plus this time. Average profit plus, what is the Z number? Z number for the 95% confidence level. It's 1.96 times standard deviation divided by square root of number of simulations, which is 1000 for this case. So when I press F9, since realizations are changed, the confidence interval values are changing, as you can see. Okay, step 6, one-way data table. So I'm gonna use average profit, this profit to obtain the one-way data table between to see how the average profit changes according to different order quantities. So for the data tables, always we are calling our function, which is average profit in this case. So I make a cell reference to this cell. Enter. Then I'm gonna make a careful range selection as follows. Then data, what if analysis, and data table. I have just one way, and I have my values in the column. So what are those values? Those values are the possible order quantities. So I'm gonna make a cell reference to the order quantity cell, which is this B9. Okay. So let's calculate this best order quantity. So I put this max match index for your reference. So these are formulas, but I can apply these three formulas in one step as follows to find the optimal or best order quantity. So I'm gonna come to this yellow cell equal to. So this cell should return the order quantity. So we're gonna use index. One of the values in this range will be optimal. I'm gonna use match function. I need to match the maximum of this number. What is the maximum of this number? Okay, I'm gonna look at this maximum within this range, and I use exact match. I close the parentheses for match, and I need to close the parentheses for index, and we are done. So let's press F9 to observe how our order quantity, best order quantity, and the confidence interval are changing. So as you can see, when I press F9, each time we are generating one different simulations, and we may obtain different optimal order quantities. Also, let's look at the demand values here. They are changing. Sorry. So this is the idea of simulation in a two period problem setting. Thanks for watching.